Hello everyone, welcome to Vishesh Educational Videos. So in this video, I am explaining one of the important topics of operating system, Peterson's solution. So let me start with the explanation. So to explain this concept, I am considering a scenario where I am going to assume that the two processes wants to access the same data, right, simultaneously. So two process wants to access the same data simultaneously, but there is a problem here. What is that problem? When two process tries to access the same data concurrently or simultaneously, there is a chances that incorrect data can be read or written by one of the processes, right? I can't assure that the data that is going to be read or written by that process is correct, right? That is the problem here. So I'm not going to guarantee that the data what is going to be read or what is going to be accessed by the process is a correct data, right? That is the problem here. So what is the solution here? When two process wants to access the same data, I can't guarantee that they are going to access the correct data. Here, what is the solution means that critical section problem is the solution here. So what is the critical section problem? The critical section problem, right, is going to assure you that the processes can correctly cooperate with each other. That means the critical section problem is going to assure you about the synchronization. For example, here every process that wants to communicate will have some critical section. In that section, when a process is in critical section, the process can do some tasks such as updating a table, changing the variable, writing the file, and so on. The most important thing here is when a process is executing in its critical section, no other process can, right, execute in its critical section. That means when a process is executing in its critical section, no other process is allowed to execute in critical section. Now you can ask a question, how it is going to overcome this problem? Suppose if two processes are sharing a shared data, that is a same data, no two processes can access that same data simultaneously, right? So only one process has to use that data. Only one process that is in critical section has to use the data, and other process that is not in the critical section, that has to wait for its turn. When the turn comes, that process can use the data in its critical section. Thereby I am allowing only one process to access the same data at a time, right guys? So you can see here, so this is the critical section structure where a entry section is there and a exit section is there. One process can enter the critical section. When one process enter the critical section using entry section, other process can't enter the critical section. Thereby I can assure you that the data is not going to be accessed by the other process that is not in the critical section. Thereby I can avoid these problems, right? Understood guys? If you have any doubts, please post your doubts in the below comment section. So now, what are the three conditions that should be met when you are implementing the critical section? Means the first condition is mutual exclusion. That means when a process P is executing in its critical section, then no other process can be executing in its critical section. That means at a time only one process should execute in its critical section. Now you can ask a question, what is the use? So when one process is executing in a critical section, no other process can do the changes, right? That's why your information will be safe, that, right? So next is progress. What is that? So when a process is executing in critical section, only the interested process only the process that are interested to enter the critical section, those process should be allowed. Understood, guys? If the process is not interested, then no worries, only the interested process should be allowed to enter into the critical section. And remember, and the decision which process has to enter the critical section, that is to be taken care in a limited amount of time. Once I take the example, you will understand this in a more better way. So next is bounded waiting. So what is bounded waiting means? There is a limit for every process that how many number of times it should enter a critical section. A process can't enter the critical section as many number of times as it wants. Now I have to fix a limit. I have to fix a bounded limit. Understanding, guys? So once I take the example, you will easily understand these conditions. So far what I told, so I told about a scenario where I am assuming that the two processes wants to communicate with each other by sharing the same data. So the problem here is when a two processes share the same data simultaneously, I can the state can produce a error result, so the ultimate result, the end result will be an error. So how to avoid this means you can use a critical section. So critical section assure you about the process that is going to execute in its critical section. That means it is going to only one process should execute in its critical section, and that process has to wait until the one process critical section is over. In this way, I am going to assure you that the data will be accessed only by the process that is in its critical section. Guys? Now we will see this. So far I told you about the critical section, So theoretically I told you that I can use a critical section, thereby I can avoid the two process making changes to the same data. I can allow only one process at a time, thereby I can protect my data like that, But how to implement that? I can implement that by writing a program. Theoretically I told you, but how to implement that means I can write a program to implement a critical section, or I can write a software to implement a critical section. That program is nothing but a Peterson's solution. That program is nothing but a Peterson's solution where Peterson's solution is going to give this programmatic solution to my problem. So if you have any doubts regarding critical section, you can refer my previous video where the link for that video is given in the description section. So understood, guys? So Peterson's solution is nothing but a software program to solve my critical section problem. Now I will move on to the explanation of a Peterson solution. So Peterson's solution is restricted to two processes. Remember this, it is very important. So Peterson solution can be applied between only two processes. Getting, guys? And I consider the two processes as P0 and P1. And Peterson's solution and Peterson solution uses two data items. The one is turn and one is a boolean flag. Flag is an array, and it's going to that flag is going to hold two values. That's why it's a boolean type, So next the variable turn indicates whose turn it is to enter its critical section. For example, if turn is 1, the process P1 can enter the critical section. If turn is 0, the process P0 can enter the critical section. Understanding, guys? And the flag array is used to indicate if a process is ready to enter its critical section or not. For example, if a flag 1 is true, that indicates that process P1 is ready to enter the critical section. If flag 0 is true, that indicates that process P0 is ready to enter its critical section. So now we will see the code. I told you, Peterson's solution is a program for a critical section program. That is a solution program, right? So this is the code for the process P1. You can see there there is a entry section and a exit section, right? And this is, and first what I'm going to do means I'm going to explain this code for the process P1, how it is going to execute, right? See here. So initially I'm going to assume that flag 0 and flag 1 will be false. Here you can observe there, see the highlighter, I used two flags, flag 1 and flag 0. So initially I'm going to assume that flag 0 and flag 1 will have the value false. And turn, I am going to use one more variable, turn, you know that, right? Turn indicates which process has to execute now, and flag indicates which process that is ready to enter the critical section. And initially the turn variable will be empty. Understood, guys? So flag 0 is false, flag 1 is false, and turn is empty. Now I will explain the process now. See here. So first flag 1 is set to true. You can see here flag 1 is set to true. That means what? When a flag 1 is set to true, that means that P1 is ready to enter its critical section. P1 is ready to enter its critical section. But now you can see another statement here, turn is equal to 0. Here you can see that P1 is ready to enter into its critical section, but it is giving chance to the process P0. It is giving chance to the process P0 to enter into its critical section. So understood, guys? So flag 1 is equal to true means P1 is ready to enter its critical section, but it is giving chance to P0, that is turn is equal to 0, to enter the critical section. So now we will see P1 is giving a chance to P0, right? Now we will see whether P0 is going to critical section or not. So we will check the condition here. So flag 0, this is the AND condition here, both the conditions should be 0. So flag 0 value I have to take. So what is the flag 0 value here? False. Flag 0 value is false, and turn value is what? 0. But according to the AND condition, what is the condition here? See here, flag 0 is equal to 2 and turn is equal to 0. But you know that flag 0 is what? False. Flag 0 is not equal to true. That's why one of the condition within the while is false. So that's why condition fails. So that means that process P0 is not interested. So process P0 is not ready. So process P0 is not ready. That's why when a while condition fails, process P1 enters the critical section. So and process P1 executes in its critical section. But while coming out, while exiting, process P1 is again setting the flag 1 to false. Here you can see it is set at the flag 1 value to true, right? But while exiting, it is setting the flag 1 value to false. Getting, guys? Any doubts? So see here again P1. So sorry, it's actually it's mistaken here. So flag 1 is again P1 enters the critical section. It's execute, but again P1 sets the flag 1 value to false. Getting, guys? Flag 1 value will again be set to false. In this way, here P1 is executed in its critical section. It has given the chance to P0, but P1 is not interested. That's why P1 is executed. Now we will see the code for the P0. So this is the code for the P0 here. So now I will explain the process. See here. So here flag 0 will be, initially flag 0 is false, flag 1 is also false, turn will be empty. You know that these are the initial values. So now I will explain the process. See here. First what process P0 will do means it will set the flag 0 to true. That indicates that process P0 is ready to enter into its critical section. That is, process P0 is ready to enter the critical section. But see here, but turn is equal to 1. turn is equal to 1 means it is going to tell which process turn it is. Process P0 is giving the chance to process P1 to enter into its critical section. Anyway, process P0 is ready, but it is giving chance to the P1 to enter into the critical section. Now we will see whether P1 will enter the critical section or not, right? So condition we will see, flag 1 is equal to 2. Flag 1, you can see here, flag 1 is false. I only changed the flag 0 to 2. Flag 0 to true. I not changed the flag 1 to false. That's why obviously one of the condition in while is false. That indicates that, see here. So flag 1 is equal to true and turn is equal to 1. But you know that flag 1 is what? False. Flag 1 is false. The condition fails. So process P1 is not going to enter the critical section because it is not interested. So P0 enters the critical section, executes in its critical section, but while coming out, right, P0 again set the flag 0 to false. Right guys, understood? So in the first code here, P1 executed in its critical section, but before executing it has given the chance to P0, but P0 was not interested. Here P0 executed in its critical section, but before executing it has given the chance to P1. So when you execute these processes, right, individually, no problem. There is not a problem. You can execute this process separately, no problem. But when you interleave these processes, interleave this means when you mix the statements of these two processes, right? Now we will see that what happens. See, assume that P0 is executing in its critical section. Now P1 is requested to execute in its critical section. So P0 is already executing in its critical section. At the same time, P1 is also requesting to enter in its critical section. That means both P1 and P1 are mixed here. P0 and P1 are mixed here. See here. So see here. So P0 is already executing in its critical section. So P1 is now requesting to enter the critical section. So as per the critical section problem, even if P1 is requesting to enter its critical section, they needs to be executed simultaneously. According to the critical section problem, only one process has to execute in its critical section. No two processes can enter the critical section at the same time. We will see that whether it is working like that only or not. Now P0 executing in its critical section, so flag 0 is equal to true because already P0 is set at the flag 0 to true, and flag 1 is equal to false. Flag 1 is false because P1 is not executing, right? P0 is executing, and that's why flag of 0 is set to true, and turn is equal to 1. Already P0 is changed the value turn from 0 to 1. That means P0 has given the chance to P1 initially, but P1 was not interested. That's why P0 enter into critical section, and it is still now it is executing in its critical section. But in the middle, P1 is requesting to enter into the critical section. Now we will see how it is going to work. Now P1 will request to enter the critical section. See, what we will do means, now P1 will check the condition because it is requesting to enter the critical section, but P0 is still executing in its critical section. So P1 will check the condition, flag is 0 is equal to 2 and turn is equal to 0. Yes, you can see here flag 0 value is what? True. It is changed by P0, right? So flag 0 is equal to true. Yes, this condition while this part is true. Turn is equal to 0. Yes, you can see here before coming into this while statement, P1 changed the turn value to 0, right? Because P0 is executing, right? That means turn is 0 only. So now you can see the condition is true. So now this while statement, what it does means it will do nothing. You can see this loop do nothing. It just keeps on looping in the while. P1 just enter the while loop and P1 keeps on looping in the while loop. Right? It loops until P0 executes and P0 changes the flag 0 to false. See, P1 loops up to what time it loops? Up to P0 completes its execution, it's a critical section, and change the flag 0 value to false, from true to false, from true to false. Until that time, your P0 simply loops in the while. Now, we will see what happens when the P0 changes the value of flag 0 to false. So, once the flag 0 changes to the false by P0, the condition fails in P1. How it fails? You can see here. Now the flag value is changed by P0 to false. See, while flag of 0, earlier it was true, but now it is changed to false. That's why the condition fails. P1 comes out of the while loop. It will enter into its critical section, right? And it will execute. Understanding, guys? So here you can see here, P1 waited until P0 finishes its critical section, then P1 executed its critical section, right? So P1 waited until the P0 completed its critical section, then P1 started to execute in its critical section. So what it implies? So even if we execute P0 and P1 concurrently, only one process is allowed to execute in its critical section at any point of time. Here P0 was executing, only after P0 completed its execution in critical section, then only P1 is allowed. So even if these two processes allowed to execute concurrently, no problem, right? Only one process is allowed to execute in its critical section. So as per the critical section problem, only one process has to use its critical section. Thereby it avoids of changing the data. Even here we mixed the statements. Only one process is allowed to execute in its critical section. Thereby I protected my data. Right, guys? Now, so you know that there are three statements. We have seen the three statements here. Which one? These three conditions: mutual exclusion, progress, bounded waiting. These three conditions should be met by the Peterson solution. If these three conditions met, then I can say that this condition is applied to the problems. See? Now we will check this mutual exclusion is preserved, the progress requirement is satisfied, and the bounded waiting requirement is met. We have to check these three conditions. Now see here, mutual exclusion. Mutual exclusion means if process P is executing in its critical section, no other process can be executing in their critical section. So you have seen that in the previous slides, right? So here you have seen that. So while P0 is executing, P1 is not allowed. Even if it is requested also, it is not allowed. Once after the P0 is completed its critical section execution, then only P1 is allowed to complete its execution in its critical section. So anyway, we will see it once. So see here. So now P0 is executing in its critical section. So P0, it is executing in its critical section. So it's changed the value flag 0 to true, and it's changed the value turn to 1. So flag 0 true and flag 1, that is flag 1 is equal to false, turn is equal to 1. So see here, so flag 0 is equal to true, P0 is changed the value flag 0 is equal to true, but flag 1 still it is false because P1 is not executing, P0 is executing. That's why flag 1 remains same, but flag 0 value changed to true here. So turn value is also changed from empty to 1 by P0. So you can see that the same explanation I am doing here. P0 executing in its critical section. Now we will check. P1 will request to enter its critical section. P0 is executing its critical section, but P1 is requesting again to enter into its critical section. But so what P1 will do means it is check the condition. So flag 0 is equal to true, but flag 0 is what? Flag 0 is true only, but turn is what? Turn is 0 only. P1, before checking the while loop, it's changed the turn value from 1 to 0. The condition is true. That what does it means? P1 enters the while loop. It loops in the while loop only until P0 completes its execution. Once the P0 completes its execution, it will change the flag of 0 to false. Now you can see here, flag of 0 earlier was true, right? Now P0 is changed to false. Once that false value is changed to false, this condition fails. So P1 comes out of the loop and executing in critical section. P1 comes out of the loop, P1 executes in critical section. Same explanation I am repeating here. So but see here, one thing you have to remember. Here P1 waited until P0 finishes its critical section, right? So P1 waited until P0 finishes its critical section. So even if we execute P0 and P0 concurrently, only one process is allowed to execute in its critical section, right? So what does it means? Mutual exclusion holds good. Here only I allowed process P0 to complete its execution first. Only after that I allowed P1 to execute in its critical section. That is, mutual exclusion is preserved here. I allowed only one process to execute in its critical section. First property met here. Understood, guys? Now second property. So progress. Don't get confused here. Very simple here. Progress means you have to allow the processes that are interested to enter the critical section. If the process is not interested, just leave them. Only you should allow the processes they are interested to enter the critical section. And along with that, you have to take the decision which process has to enter the critical section in a finite amount of time. That means you can't take the decision indefinitely. You have to take the decision in a finite amount of time, and only interested process has to enter into its critical section. Don't worry, we will see this now. So see here, initially, now I will consider the value P initial values. I will consider the process P0. I will start from the process P0. So you can see here flag 0 value is also false, flag 1 is also false, turn is equal to empty. These are the initial values. So first step what we will do means P0 will set flag 0 to true and set turn is equal to 1. You know that flag 0 is equal to true means what? P0 is interested to enter into the critical section, but it changed the turn to 1 means P0 is interested but giving the chance to P1. Now you know that no condition is checked, so obviously condition is false here. Flag 1 is what? Flag 1 is changed to true, right? Flag 1 is changed to true, condition false. So once the condition is false, you can see here P0 enters the critical section. So P0 enters the critical section. That means what? P1 is not interested to execute in critical section. That's why P0 is executing in its critical section. Remember here, P1 is not interested. Here what I am doing, I am allowing only the interested process to execute in its critical section. If P1 is not interested, no worries. P1 is executing in its critical section. So what is progress? You have to allow only the interested process to execute in its critical section. I am doing that. I am allowing the P0. I asked the P1. P1 told that I am not interested because this condition is false. You can see flag 1 is false, but according to the AND condition flag 1 value should be true. So obviously P1 is not interested, P0 entered it and executed it. So that is the second condition. Only interested process entered here. For P1 also same applies. For P1 also same applies. See here, flag 1 is equal to true means that means P1 is interested to enter the critical section, but turn is equal to 0 means it is asking P0 whether it is interested or not, right? So while flag is equal to 0, what is the flag 0 value? What is the flag 0 value here? False. But see, flag 0 value initially, what is the false? What is the value here? False. So condition fails. P1 enter the critical section and executes. It asked the P0, but it is not interested. The same thing applies to P1 also. Only the interested process has to execute in its critical section. That is the progress. And one more important thing, you have to take the decision in finite time. That means, see here, I'm using to take the decision which one has to enter its critical section. How many statements I am using? See, only one while loop I am using here. How many statements I am using? Only one while loop I am using. Finite number of statements I am using. That's why I am taking the decision that which process has to enter the critical section in only one statement. In a finite amount of time I am taking the decision. Second condition preserved. Getting, guys? So now what is the third condition? Third condition is bounded waiting. So what is the bounded waiting? So bounded waiting means I can't allow only one process to execute all the time. I can't do that. I need to give chance to every process. I have to put a limit on the number of times a process can enter its critical section. If I allow only one process to execute in its critical section all the time, what happens? So some process may wait for indefinite amount of time. They won't get any chance, right? That is the problem. That's why I have to give equal chance to all the processes. That, right? I have to give equal chance to all the processes. See how it is going to be done. So see here, same thing, you know that. Now I will consider P0 same value. I don't want to waste the time. Flag 0 is equal to false, flag 1 is equal to false, turn is equal to empty. So first step, P0 will set the flag 0, and but it will ask the P1 whether it is interested or what. But P1 condition is checked, obviously it will become false. So that means what? P1 is not interested to execute in its critical section. So now what P0 will do means, if P0 will do execute in its critical section, after completing the execution, remember here the actual thing you have to remember here. Here after completing the execution its critical section, P0 is changing the value flag of 0 to false. What does it means? That means P1 can execute now, right? So P0 has given the chance to P1 again. Even if P1 wants to execute again also, what it is doing means, even if a P0 wants to execute again, what it is doing means, it is giving chance to P1 once again by changing the value of flag 0 to false. That means every time when a process executes in its critical section, other process will get a chance every time also, right? Whenever the P0 executes in its critical section, after execution, P0 will give one more chance to P1 to enter into its critical section. If it is interested, P1 can enter it and execute. Again, if P1 is not interested, again P0 will execute in its critical section. Again, it will change the value to false, flag of 0 to false. Again, it will give chance to P1. If again P1 is not interested, this process goes on repeating. P0 will execute, but after the completion, every time after the completion of the critical section execution, every time P0 will give the chance to P1. Why? How it is giving the chance? When flag 0 is set to false, you can see here P1 flag 0 condition become false. Flag 0 is false is what? Condition fails. P1 enters it in its critical section. Thereby P1 enters it critical section. So third condition preserved here. So I am giving P1 also a chance. I am giving P1 also a chance. So it won't starve. P1 won't starve in for unlimited amount of time. P1 will also get a chance, same as P0. Getting, guys? So 3 conditions as met here. So getting, guys? So that's it, guys. Hope you understood the concepts. Suppose if you have any doubts, please post your doubts in the below comment section. Thank you. Thank you for watching the video. Please don't forget to subscribe to my channel. Please click the bell icon to get the notifications. And don't forget to like and share.